In lesson 1-9, we're going to solve addition and subtraction equations. So we're going to solve those types of equations using the addition and subtraction properties of equality. Okay, to solve an equation, that just means to answer or evaluate. Another word you might see is to simplify. All these words kind of mean the same thing: to answer, evaluate, simplify, solve. The solution would be like a equals 3, where you are identifying what the variable is equal to. Inverse operations means that, like, if in the equation you're adding a plus 3 equals 7, in order to solve, you would have to do the inverse. Inverse meaning opposite operation. Okay, so we always do the opposite in order to solve. That would cancel this out, make it 0, and we'd say a equals 4, and that would be our solution. So if you subtract the same number from each side of an equation, the two sides remain equal. All right, if we think of like a teeter-totter here, okay? There's the flat bar, and in the middle we have our fulcrum, or our balance point. All right, that balance point we think of as the equal sign. All right, so this side of our equation has to be equal to this side. So in looking at this equation here, okay, imagine us putting the number 7 on this side and then 15 plus c on that side. Okay, well, we know that it's balanced right now because our equal sign is right in the middle. So in order to get c by itself, and for us to figure out what c is, we're going to take this 15 and then move it over there. But while we do that, we need to keep the whole thing still balanced and equal. All right, so while we're doing that, you know, if you're doing this in your homework, of course, you'd copy 7 equals 15 plus c. All right, so we need to think of what is the inverse operation. Well, this is a positive 15, so in order to get rid of this, what we want to do is we want to turn it into 0, okay? So how do we get rid of 15? We have to subtract 15. Now, whatever you do to one side of the equation, you have to do to the other, okay? So again, think of this like your teeter-totter over here. Okay, if you subtract 15 over here, you have to subtract 15 over here, or otherwise your teeter-totter will become unbalanced. Right? If we take 15 off this side, obviously this side is going to go up, and this side is going to go down. But if we take 15 off of this side also, then we will remain equal, which we have to keep it equal for the equation to work out, for us to be able to solve it. So it is really important that you actually show me that you're doing the step on the right side and the left side. Whatever you do on one side of the equal sign, you must do to the other. So I do need to see this done on both sides. All right, so let's draw your solution line down now. We need to bring everything down. So the c is here, bring the c down. The equal sign is here, we can bring the equal sign straight down. Notice how I'm bringing everything straight down. I'm keeping it all lined up and nicely organized. Now, here, it's really important to notice that we are taking 15, we're subtracting 15, so this is going to become 0. Okay, remember when we talked about the identity property, okay, c plus 0 equals c, right? So we don't actually have to write 0 there, we can just say c equals, okay? You could say 0 down here, but there's no point because we know that c plus 0 equals c. All right, that's your identity property. That's why we learned about that property. Now, I have $7 and I owe $15. Okay, that's what the 7 minus 15 means. I have 7 and I owe 15, so it means I'm going to owe, all right, because the absolute value of 15 is bigger. We're going to owe 8. All right, so what we can do to check this, obviously we want to be able to check all of our problems. You can plug this in your calculator and actually check. It's 15 plus negative 8. Okay, and when you plug that in your calculator, you're going to get 7. All right, so that proves that we checked our answer. Now, your solution to this problem is right here. Now your solution wouldn't mean anything if you didn't show this work. Again, I can't stress enough, you have to show minus 15 on both sides of the equal sign. Okay, so we shouldn't have any question with what work we're supposed to show. All right, this property of equality is shown up here. We have 7 equals 7, which we know is true. If you subtract 3 on one side, you have to do it to the other side. Again, that teeter-totter effect, and kind of what I'm trying to explain to you right here. You have to do it on both sides. All right, let's try another example. T plus 7 equals 12. All right, so again, we have to keep our teeter-totter balanced. In order to do that, whatever you do over here, you have to do over here. All right, so to get rid of a positive 7, okay, this is a positive 7. To get rid of that, we have to subtract 7. Whatever you do to one side, you have to do to the other. So you can almost put the equal sign right here. Negative 7 equals what? Well, you have to write it. All right, negative 7 equals negative 7. Now we write our line across. All right, now bring everything down that you can. So we have our T. All right, we still have our equal sign. Okay, think again of the identity property. You don't have to write 0 because we know that T plus 0 equals T. But again, I'm just keeping everything lined up. Notice how I didn't write the T over here because it doesn't belong there. We keep it lined up. And then I have $12 and I owe $7, so that means I'm going to have 5. All right, so my solution is right there, T equals 5. And you don't need to rewrite it so that way they're closer. This is totally fine, and I actually like that because then it shows me that you have the spacing down. If you want to rewrite it as T equals 5, that's totally fine. So that way it's nice and close, but this is okay too. You don't have to do the extra step. Okay, now the same thing with goes with subtraction as goes with addition. So if we have 7 equals 7, you add 3 to both sides, and we get 10 equals 10. All right, so the same thing here. Again, this is not, we don't want to think of this as a positive 4. We want to think of it as a negative 4, right? This is why we practiced changing everything to addition, so that way we could more easily recognize that this is a negative. You know, we don't want to think of this as, you know, subtraction so much as this is a negative 4, okay? If you can't see that, then go ahead and change it to addition. Make it a negative. All right, now how would we get rid of a negative 4? Again, we want to keep this teeter-totter balanced. So to get rid of the negative 4, we have to add 4. We have to get a positive 4 on both sides, okay? It's like you're adding 4 here, so you have to add 4 over here to keep it all level and balanced. All right, now we draw our line across. We bring our K down. Bring our equal sign down. All right, this is going to be equal to 0, so you don't have to write it. It zeroes out. And if you owe $14 and you have $4, it means you still owe $10. All right, so my final answer would be right there. K equals negative 10. Again, get in the habit of checking this with your calculator. You could say negative 10 and then minus 4 gives you negative 14. Your calculator will agree. All right, so the next problem here, all right, again, we have a negative 5, negative 5. So let's go plus negative 5. Okay, again, if you're doing this in homework, you're going to have to copy it out of the book. 11 equals W minus 5. And you can go ahead if you want to, copy it out of the book, and change this to addition right away. So you're going to say W plus negative 5, just so that way you can have it written in your paper right away like that. Now, next step, okay, how do we get rid of this negative 5? Again, you always look on the side of the variable, because ultimately, what is your goal? You're trying to get the variable by itself. You're trying to find out what that letter stands for. So, to get rid of a negative 5, you got to add 5 to both sides. All right, draw your line. Bring down your variable, bring down your equal sign. So W equals, all right, this is going to be 0. W plus 0 equals W, so you don't have to write it. Okay, I'll write that up here. W plus 0 equals W, so you don't have to write the plus 0. If you have 11 and you have 5, we have 16. Okay, if you want, you can check that out. All right, if you have 16 and you subtract 5, you're going to get 11. So that does check with your calculator if you want to look at that, and your answer would be right there, your solution But again, your solution doesn't mean much if you don't have this work here. I need to see the work. All right, two angles are supplementary if the sum of their measures is 180 degrees. Okay, so it's showing that these two angles are supplementary. Okay, so meaning that this angle plus this angle equals 180 degrees. We can tell that because this is a straight line. 180 degrees is a straight line. So write and solve an equation to find the measure of angle R. Well, I know that R plus 140 has to equal 180 degrees. All right, because this angle R plus this angle, okay, has to give us our total 180 degree angle. So in order to find out what R is, I have to subtract 140 from both sides, okay, because I'm trying to solve for R. It would do us no good if we subtract 180 from both sides, because all we're going to get is R plus a negative number equals 0. So we still don't know what R is. So we need to take everything on the variable side and move it over. All right, this is going to be 0. Okay, we need to move our variable down. R, bring your equal sign down. R plus 0 we know is R, so we don't have to write it. And then over here, I have 180, I owe 140, so that means R equals 40 degrees. Now this is a word problem, so it's important to include your label, that degree label. Okay, so R equals 40 degrees. All right, at high tide, the top of a coral formation is 2 feet above the surface of the water. This represents a change of -6 feet from the height of the coral at low tide. Write and solve an equation to determine h, the height of the coral at low tide. Okay, so what we have to understand here is that when we have high tide, that actually means that the water level is higher. And so therefore, if we had, let's say this is our coral over here, all right, and at high tide, obviously the water level is going to be higher, and therefore less of the coral exposed. And then if I use the green color here, this is low tide. Obviously, we're going to have more exposed, okay? So it could be a little confusing here because when you think high tide, you should have a higher number. Well, if you have high tide, that means the water is higher, and so we have less of the coral showing. All right, so H is going to be the height of the coral at low tide. So we want H to be a bigger number than 2. All right, going into this, so we need to try to set this up. All right, so if I have a change of -6 plus our H at low tide, and that's going to equal our high tide height. Okay, now if we look at this, all right, how do I get rid of this -6? Well, I'm going to have to add 6 to both sides. All right, and obviously this can be 0, and we don't have to write it. We just bring our H down, bring our equal sign down, and 2 plus 6 equals 8. And you want to include units here because it is a word problem. So the height of the coral is 8 feet above the water at low tide, which is bigger than the 2 feet. So this answer then is making sense for us. All right, solve. A -5 equals z minus 16. Again, if you see this in your book, you're going to copy -5 equals z minus 16. Okay. Now it's important again to recognize this is a -16. Okay, if you need to, write plus -16. Okay, in order to get rid of this, because we're looking at the set of the variable here, we need to get rid of this so we can get z by itself. Add 16 to both sides. Draw your line across. All right, this is going to be 0, so we don't have to write it. Bring your z down. Bring your equal sign down. All right, if I have $16 and I owe $5, it means I'm still going to have 11. All right, so z equals 11 will be my solution. Don't forget to check it, so we can go 11 minus 16, and our calculator is going to tell us, yep, that is a -5, and so it checks. All right, that's our last example for solving addition and subtraction equations. Be sure to check the Moodle page to find out what your homework is.